Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about the Leetcode problem number 350, intersection of two arrays 2. Given two integer arrays nums1 and nums2, return an array of their intersection. Each element in the result must appear as many times as it shows in both arrays, and you may return the result in any order. See this example: 1, 2, 2, 1 and 2, 2. What are the common elements? It is 2, 2. Right? Now here 4, 9, 5, 9, 4, 9, 8, 4. Now you have to return 4, 9 because 4 is occurred one time here and 2 time here. But the common is only one time. And 9 is occurred one time here and 2 time here. Common is only one time. So you have to return 4, 9. You can also return 9, 4, 2. Right? It also correct answer. It also accepted. Now how to approach this problem? Whenever I have this problem, I want to count what is the count of every elements in two arrays, right? I want to count what is the count of the every elements, right? I just take 1, 2, 2, 1, 2, 2, right? Now I have to count just in D1 is a hash map. I'm counting this every elements. So what will the count? 1 is occurred 2 times, 2 is occurred 2 times. Now here in D2 take for example 2 occurs 2 times. Right? Now I'm going to check whether this 1 is in this D2. No. There is no 1. So if there is no 1, I don't want to add it in the result, right? Now I'm going to check whether this 2 is in this D2. Yes, it is in D2. And whether I want to take how many count of that 2. It is 2 because here also 2, right? So I will take as 2. Now 2, 2 will be my answer, right? Now let us see the example for next question. 4, 9, 5, and another one is what? 9, 4, 9, 8, 4. 9, 4, 9, 8, 4. Take for example. Now, what is my hash map? Now, what is my count? 4 will be 1, 9 will be 1, 5 will be 1. For this array. For this array, 9 will be 2, 4 will be 2, 8 will be 1, 8 will be 1. Now we are going to proceed the steps. Whether 4 is in this array and what is the count? It is 2. Whether we want to take 1 or 2. We have 4 and 4, 4. We only take one time, right? So we want to take minimum count. So I will take 4 as my result. Now whether 9 is in my another hash map. Yes. Here it is 2, here it is 1. I have to take only one 9 because minimum. 5 is in my hash map. No, there is no 5. Then it is my result. This is my output, right? So this is the approach. Here this is the approach number 1. Let me write here. This is the approach number 1. Here we are using hash map 1 and hash map 2. So the total of time complexity is O of pushing this all into hash map, So it will be n log n plus m log n, right? Then we are checking whether this element is here and what is the count here. That can be like n into log of m. That's all. That's not a big complexity, right? So overall it will be like this one, this complexity, time complexity. And what is the space complexity? It will be O of n for constructing this hash map and O of m for constructing this hash map. So this is my space complexity. Is the second hash map is needed? Is the second hash map needed? The answer is no. So this can be reduced. This can be reduced, and we can make the time complexity as like this. But when? And how we can make this? Just assume 4 is occurred 1, 9 is occurred 1, and 5 is occurring 1 in the first array. First array, that is 4, 9 and 5, right? In second array, it is, what are the elements? 9, 4, 9, 9, 4, 9, 8, 4, right? Now I'm going to update in this hash map. I take different color. Now, whether this 9 is in this hash map. Yes, it is. What is the count? It is 1. Reduce 1, and update in result as 9. Reducing 1, it will become 0. Now, 4 is in hash map. Yes. Reduce 1, it will become 0, and update 4. Now, 9 is in hash map. Yes, but count is 0. That means 9 is already present, but it's not as much as count as the second array. Okay, don't update. 8 is in hash map. No. 4 is in hash map. Yes, but the count is 0, so don't update. So the answer is 9, 4. So 9, 4 is the output. So this is the hash map solution, where the time complexity and space complexity. Telling about the time complexity taken as we go of n log n to insert into the hash map, and plus I want to iterate to whole m, so m into log of n to search in this hash map. This is for searching in the hash map, and this is for iterating. To this array, right? And talking about space complexity, it is only n. To insert this n, say here is 3 elements, and the size in the worst case will be 3 for this hash map, right? So the space complexity will be O of n. So this is my solution. This is my second approach. Fine. This is my second approach. Can we still optimize it? As we already studied that we can also use 2-pointer approach, right? But how to use 2-pointer approach? As you see, we already solved intersection of 2 arrays before this problem. In that, I have used 2 pointers by means of sorting these 2 arrays. By use of sorting these 2 arrays. Now, let us consider that approach, and let us build the approach. Let us build the induction. See here. Now the third approach is without using hash map. Or any data structure. Now how to do this? First of all, sort the 2 arrays. This is the first array. This is second array, right? Now place the pointers here. Here is a 1 pointer, and here is another pointer. Whether 1 and 2 are equal? No. Whether I want to move this 2 here, whether there is a possibility of occurring of 1 right to the 2? No, because it is in sorted order, right? But in rightmost of this 1, there is a possibility of occurrence of 2, right? So I can move this here. Whether this 1 and 2 are equal? No, 1 is less than 2, so move again. 2 and 2 are equal? Yes. Then add it to the output 2. Again plus 1. Move the shift the both pointers ahead. Now 2 and 2 are equal? Yes. So update. So this is my output. This is the approach by using a 2-pointer approach. First I am placing a pointer here and a pointer here, right? This is called as a parallel pointer method. Right? Okay, fine. Now talking about the time complexity. What is the time complexity and space complexity? Time complexity is, first of all, I am going to sort this array. So n log n plus sort another array m log n plus fully traversing. So it will be n plus m. Right? And space complexity is, for sorting it uses n, and for sorting this array of m size, it uses m. Okay, because it uses merge sort So this is length m, this length n. So these are the two approaches. Three approaches. Totally there are three approaches, but 1 and 2 are mostly common approach. Just we are reducing a space. Fine. And third approach is without using data structure, that is hash map. Without using that hash map, we are using the two pointer approach. Let us see the code. See here, result is equal to just an empty list. I am creating a dictionary, that is hash map, for I in nums1. If I is not in D, if I is not in D, just update D of I is equal to 1. Else D of I plus is equal to 1. I am just counting 1 by 1. Then for J in nums2, now the tricky parts come. If J in D, if J exists in D and also its value should be greater than 0, then only I want to add that element into my result. Then just reduce the count by 1. Now at last just return the result. Fine. So this is the first approach. Let me execute it. Submit it. Yes, it is submitted successfully. Now going to the second approach. The second approach is two pointer approach. I'm just sorting this two arrays. Then I is equal to j is equal to 0. Then result is equal to empty array. Then I am storing n1 and n2 as a length of nums1 and nums2. While I is less than n1 and j is less than n2, I will iterate to this loop. If nums1 of j, I is less than nums2 of j, then I will update I by 1, right? Because I is smaller than j. There is a possibility of getting the jth element in right side of array. That's why I am just shifting I by 1. If it is opposite, if the condition is opposite, I will shift j by 1. Else the two elements are equal. The two elements are same. So I will update them into the result. Then I plus is equal to 1. Then j plus is equal to 1. Then return the result. So this is my second approach. A two pointer approach. Parallel pointer type. Yes, it is submitted successfully. So these are the two approaches for this question. Thank you.